F naught is the carrier equation. So the carrier signal is represented by A cos 2 pi F naught t, where A is the peak amplitude of the carrier, where F naught is the frequency of the carrier. Is it okay? And in phase shift keying is a digital modulation technique, PSK, phase shift keying, PSK, which is simply known as PSK. P, capital P, capital S, capital K. Capital P means phase, capital S means shift, K means keying, phase shift keying. In phase shift keying, in PSK is a PSK comes under digital modulation technique. The PSK modulator కి మీరు అప్లై చేసే మెసేజ్ సిగ్నల్ ఎలా ఉంటుంది, PSK modulator కి అప్లై చేసే క్యారియర్ సిగ్నల్ ఎలా ఉంటుంది అంటే, PSK the input signal that is applied to the input signal that is applied. So now look at this carrier signal. Now this is the, for example, let us consider this one as a modulator, BPSK modulator. So the message signal is binary sequence, which is digital in nature. Binary sequence which consists of ones and zeros, like will be 10 10 double double 10, ones and zeros, and your carrier signal is analog in nature. Carrier signal is analog in nature and message signal is digital in nature. The carrier signal will be in the form like this, sinusoidal form, and it will be represented by A cos 2 pi F naught t. Okay, and carrier is analog signal, analog sinusoidal carrier, and digital message signal is a binary sequence which consists of ones and zeros, which is nothing but digital message signal. Is it okay? Message signal is a digital message signal and carrier signal is a analog carrier sinusoidal signal. Okay, and now I consider this one as a carrier signal, and the power of the carrier signal is a square divided by 2, and power is represented by P, and power is equal to A square divided by the amplitude square divided by 2. Then a amplitude, represent the amplitude in terms of power, now I represent this amplitude A, which is the peak amplitude of the carrier. I represent this particular A, peak amplitude, in terms of power. So if you want to represent this amplitude in terms of power, then this will be A is equal to root 2 E per. Okay, so now I will remove the numbers, some numbers. So 66 is there on the session or not? 66 in the session is there or not? 66. Roll number 66 is there in the session or not? Hello, 66. 66. Bro, 61. 61 is there in the session or not? 61. 61. 61. Last call for the 61. 61 is also not there in the session, right? And 59. 59. I'm asking about the 59. Roll number 59. Roll number 59. Roll number 59. I will remove him. 57. 57 is there. 57 is there. 54. 54 is there.
Yes, sir.
54 is there. Next 71 is there. 71 is there. 71 is there. And 73 is there. 73 is there.
Yes, sir.
74 is there. 74.
Yes,
We'll
sir.
check the attendance randomly. So 76 is there. 76. 76. Who is number 76? 76. Number 76.
Yes.
Right. Sorry, 76 మళ్ళీ లోపలికి రమ్మని చెప్పండి. 85. 85 is there or not? 85. Who is number 85?
Yes, sir. Yes, sir.
87. 87. 86. 87.
Yes, sir.
87. Right. So if you fail to respond to me, then I will remove you from the session. Simply. So okay, all of you please be attentive to the session. Right. When I call you, so whenever I call you, you please respond to me. Otherwise, I will remove you from the session. Is it okay? When I call you, okay, you please respond to me. Otherwise, I will remove you from the session. Okay. So now this is the carrier signal which is in the sinusoidal form. Okay, this carrier signal will modulate whenever the binary signal is changed by then phase of the carrier signal is also changed by 180 degrees. Okay, you know that. So for the symbol 1, this is the equation, and for symbol 0 అంటే 1 నుంచి 0 కానీ 0 నుంచి 1 కానీ వెళ్తే నేను చెప్పాను మీకు ఆల్రెడీ, there will be a 180 degrees phase shift. Okay, here there is no phase shift here. For logic 1 there will be no phase shift here, and after 1 assume that the next symbol is logic 0. If the symbol changes from 1 to 0 or from 0 to 1, the phase shift will be 180 degrees. So cos 180 plus theta, so it will be represented as cos minus cos theta. So therefore this is the equation for logic 1, and this one will be the equation for logic 0. Logic 1 equation is plus cos 2 pi f naught t. Logic 2 equation is minus cos 2 pi f naught t. So then equation 1, this one time it is plus and one time it is minus. So whenever you need to transmit logic 1, this one equation will be plus. Whenever you need to
Sir, your microphone is muted, sir.
okay. Okay, now this is the equation for logic 1, and this is the equation for logic 0. Okay, logic 1 వచ్చిన తర్వాత logic 0 వచ్చిందంటే compulsory there will be a phase shift of 180 degrees. Okay, so that means whenever the symbol changes from digital message signal is nothing but binary sequence. Binary sequence consists of ones and zeros. If the symbol changes from 1 to 0 or 0 to 1, so therefore the phase shift, there is a phase shift of 180 degrees. For example, let us assume that the first symbol is 1, there will be no phase shift here. So for after 1, assume that the next symbol is 0. Okay, if the next symbol is 0, that means symbol changing from 1 to 0. So if the symbol changing from 1 to 0, there will be a phase shift of 180 degrees. Is it okay? So then cos of 180 degrees plus theta, cos 180 plus theta, so therefore it can be written as minus cos theta. So this is the equation for logic 1, and this is the equation for logic 0. So if you clearly look at the two equations, these two equations, one will be plus and one will be minus. So these two can be combinedly written as b of t into root 2p cos 2 pi f naught t. So this is the BPSK modulated signal waveform. So you know that a amplitude modulated signal waveform equation, frequency modulated signal waveform equation, and phase modulated mathematical equation. In the similar manner, it is the BPSK modulated signal mathematical equation. So where b of t is equal to plus 1 when logic 1 is to be transmitted, where b of t is equal to minus 1 for logic 0 is transmitted. మీరు లాజిక్ 1ని ట్రాన్స్మిట్ చేయాలన్నప్పుడు బి ఆఫ్ టీ వాల్యూ ఎంత అవుతుందంటే ప్లస్ 1 అవుతుంది. లాజిక్ 0ని ట్రాన్స్మిట్ చేయాల్సి వచ్చినప్పుడు బి ఆఫ్ టీ వాల్యూ ఎంత అవుతుందంటే మైనస్ 1 అవుతుంది. ఓకేనా? సో మైనస్ 1 ఇండికేట్స్ ఫేజ్ షిఫ్ట్ ఆఫ్ 180 degrees and plus 1 indicates there will be no phase shift. Okay, so now this is the mathematical expression. I have already clearly explained in the previous class, right? So now every one of you, this is the binary sequence. This binary sequence is converted into bipolar signal, which is by using line coding technique. So this particular binary sequence is converted into electrical format by using the bipolar non-return to zero line coding technique. So this is the electrical format of the binary signal, and now this is the binary signal, and this is modulated with the help of the carrier signal. So this is the carrier, so there will be a phase shift here. All of you please look at this. Therefore here it is 1 and 0, therefore 180 degrees phase shift, 180 degrees phase shift, and 180 degrees phase shift, 180 degrees shift. Already I explained all these things in the previous class. And now coming to the demodulator, in the previous class already I have already explained the things over here, right? Demodulator means all of you please wait a minute. Um, Demodulator diagram. So in the last class I have already explained the modulator diagram. So modulator diagram is a BPSK modulator. BPSK modulator. So first one is line BPSK.
సార్ మళ్ళీ మ్యూట్ అయింది సార్.
Someone is misbehaving in the class. Someone I identify that particular, whenever if I identify that particular person, I will give the serious punishment to that particular person. Okay, don't do this particular type of activities, right? So now every one of you listen here. So this is the is it okay right now, guys? Please tell me.
Yes, sir.
First binary sequence is there. This binary sequence consists of ones and zeros. This binary sequence is converted into the electrical form of the binary signal. Electrical form of the binary signal can be done with the help of the line coding technique. Which the line coding technique used is bipolar NRZ. So now this is given to the product modulator or balanced modulator. And another input to the balanced modulator is analog carrier signal, which is in the form of sinusoidal carrier signal, right? Okay, first here the binary sequence is there. This particular binary sequence is converted into the electrical form. This particular binary sequence is converted into the electrical form with the help of the line encoder. The line encoder used here is bipolar NRZ level encoder. Okay, so now it generates a B of t. What is B of t? B of t is nothing but electrical form of the binary sequence, which is here, this one. Electrical form or electrical equivalent of the binary sequence 1010111011. So now here at the output of the line encoder, we have electrical form of the binary sequence. Now this electrical form of the binary sequence is given as modulating signal to the balancer modulator. Electrical form of the binary sequence. This is binary sequence. This electrical form of the binary sequence. This electrical form of the binary sequence is given as input to the balancer modulator, and another input of the balancer modulator is carrier signal, and this is called a message signal or baseband signal, and this is called a carrier signal. So simply these two are given as input to the balancer modulator. Balancer modulator is nothing but product modulator. Okay, balancer modulator is nothing but product modulator. Simply it performs a multiplication between the two input signals. The two input signals are, one is a baseband signal or message signal, and second one is carrier signal. So finally this is the block diagram. This is the modulator of the BPSK modulator. So coming to the demodulator of the, every one of you, demodulator. So now I will explain the demodulator section clearly. So now every one of you listen here. So in the demodulator, BPSK demodulator or receiver, BPSK demodulator or receiver. Okay, so what kind of demodulation is it? Coherent demodulation or non-coherent modulation? So we have two types of demodulation techniques: coherent demodulation coherent demodulation, which is also nothing but synchronous demodulation. Synchronous demodulation. And the next one is non-coherent. Non-coherent. Okay, so what can anyone, what is meant by coherent demodulation? Can anyone, what is meant by coherent modulation? Coherent demodulator. Coherent demodulator or synchronous demodulator? Anyone? Anybody? Anybody, guys, please tell me. What is meant by coherent demodulation? మొన్న ఆల్రెడీ చెప్పాను కదమ్మా మీకు, ఆల్రెడీ ఎస్ఎస్ మీరు ఎన్లాక్ కమ్యూనికేషన్లో చదివారు, మొన్న యూనిట్ స్టార్టింగ్లో చెప్పాను మీకు నేను. కోహరెంట్ డీమాడ్యులేషన్ అంటే ఏంటి? కోహరెంట్ డీమాడ్యులేషన్ ఈజ్ ఆల్సో కాల్డ్ యాజ్ కోహరెంట్ డీమాడ్యులేషన్ ఈజ్ ఆల్సో కాల్డ్ యాజ్ సింక్రనస్ మాడ్యులేషన్. సింక్రనస్ మాడ్యులేషన్ అంటే ఏంటి? కోహరెంట్ మాడ్యులేషన్ అంటే ఏంటి? ఎనీవన్? నో వన్ ఈస్ దేర్ ఫ్రమ్ ద క్లాస్? Do you know or not? Please tell me, otherwise I will say you. Please tell me. మీకు తెలుసా తెలీదా అమ్మా coherent
Locally
modulation?
generated.
Right. So here all of you please look at this one. Coherent modulation. I'm concentrating on the coherent demodulation. I will highlight this one with the green ink. So now coherent modulation in the receiver we generate the carrier. We generate the carrier again, and it is called locally generated carrier. Locally generated carrier. Locally generated carrier signal. Is it okay? At the receiver side, again we need to generate the carrier signal. In coherent demodulation, at the receiver side we need to generate the carrier signal again. This particular carrier, the carrier signal that is generated within the receiver, that particular carrier signal is called as locally generated
Sir, mute అయింది sir, mic mute.
generated carrier signal. Hello, am I audible right now? Hello, am I audible right now?
Yes sir.
Right.
Yes sir.
So now I will wait a minute. Right. So now so here locally generated carrier signal is there, and this particular locally generated carrier signal, this locally generated carrier signal must have frequency equal to transmitter carrier signal frequency. Is it okay, guys? So in coherent demodulation, in the receiver side or at the receiver side, we generate a carrier signal which is nothing but locally generated carrier signal. Okay, and this locally generated carrier signal must have the frequency which is equal to the ట్రాన్స్మిటర్ క్యారియర్ సిగ్నల్ ఫ్రీక్వెన్సీ. ఓకే, మీరు రిసీవర్లో జనరేట్ చేసిన క్యారియర్ని లోకల్లీ జనరేటెడ్ క్యారియర్ అని అంటారు. మీరు రిసీవర్లో జనరేట్ చేసిన క్యారియర్ని లోకల్లీ జనరేటెడ్ క్యారియర్ అని అంటారు. మీరు జనరేట్ చేసిన లోకల్లీ జనరేటెడ్ క్యారియర్ సిగ్నల్కి ఫ్రీక్వెన్సీ ఎలా ఉండాలి అంటే, మీరు జనరేట్ చేసిన లోకల్లీ జనరేటెడ్ క్యారియర్ సిగ్నల్ ఫ్రీక్వెన్సీ ఎలా ఉండాలి అంటే, ఎలా ఉండాలి? ట్రాన్స్మిటర్ దగ్గర ఏ ఫ్రీక్వెన్సీ అయితే ట్రాన్స్మిటర్ దగ్గర ఏ క్యారియర్ ఫ్రీక్వెన్సీ అయితే వాడారో, ట్రాన్స్మిటర్ దగ్గర ఏ క్యారియర్ ఫ్రీక్వెన్సీ అయితే వాడారో అదే ఫ్రీక్వెన్సీని మళ్ళీ రిసీవర్ దగ్గర మనం జనరేట్ చేయాలి. దట్ ఈస్ కాల్డ్ లోకల్లీ జనరేటెడ్ క్యారియర్. దిస్ ఈస్ కాల్డ్ కోహరెంట్ ఆర్ సింక్రనస్. దిస్ ఈస్ కాల్డ్ కోహరెంట్ ఆర్ సింక్రనస్ డిమోడ్యులేషన్. ఓకే, సో మనం ఏ టైప్ ఆఫ్ డిమోడ్యులేషన్ వాడతాం? బీపీఎస్కే డిమోడ్యులేషన్కి ఫర్ ది పర్పస్ ఆఫ్ for the purpose of BPSK demodulation, for the purpose of BPSK demodulation we use coherent demodulation. What is meant by coherent demodulation, guys? Tell me, what is meant by coherent demodulation? Please tell me here, what is meant by coherent demodulation? Anybody please respond to me.
The locally generated carrier signal must have the frequency equal to the carrier signal at the transmitter side.
Very good, Amma. So right, the locally generated carrier signal, which is nothing but carrier, locally generated carrier signal frequency must have the frequency equal to the carrier frequency used at the transmitter side. Is it okay? Right. So what kind of demodulation we employed in the BPSK demodulation? What kind of demodulation we employed in the BPSK demodulation? So for the purpose of BPSK demodulation, we use what kind of demodulation technique? Coherent demodulation technique. Is it okay? Coherent demodulation technique. Right. So now we are going to I'm going to discuss about the coherent demodulation in step by step. సో మనకి ఫర్ ఎగ్జాంపుల్ ఫస్ట్ ఏంటి అంటే సో రిసీవ్ చేసుకున్నాం కదా సిగ్నల్. రిసీవ్ చేసుకున్న సిగ్నల్ ఎక్కడికి ఇస్తారంటే ఫస్ట్ స్క్వేర్ లా డివైస్కి ఇస్తారు. ఫస్ట్ ద ఇన్పుట్ ఈస్ గివెన్ టు ది స్క్వేర్ లా డివైస్. Next, the input is given to the band pass filter, which is equal to band pass filter, and next the signal is given to the frequency divider. Now frequency divider. Okay, and next the input is so now it is called carrier signal, locally generated. So this is a BPSK signal, locally generated carrier. How we can locally generate the carrier at the receiver side? So this is the receiver of the BPSK receiver or BPSK demodulator. Okay, so by using 3 blocks we are going to generate the locally generated carrier for the BPSK. So how we can generate by step I will explain. So okay, step number 1 is the received carrier signal. Received BPSK signal is, so S of t is equal to B of t into root 2p, okay, into cos 2 pi f naught t plus theta, where theta indicates phase shift. It is a received BPSK signal. Okay, so first the received BPSK signal is given to which one? ఇక్కడ ఏం చేస్తున్నాను నేను, ఫస్ట్ స్టెప్ ఏం చేస్తున్నానంటే, సో కోహరెంట్ డిమోడ్యులేషన్లో ఏం చేయాలి, వాట్ కైండ్ ఆఫ్ డిమోడ్యులేషన్ ఈజ్ ఎంప్లాయిడ్ ఇన్ ది బీపీఎస్కే డిమోడ్యులేషన్? కోహరెంట్ డిమోడ్యులేషన్లో ఏం చేయాలి? ఇన్ కోహరెంట్ డిమోడ్యులేషన్ So we need to generate the local carrier. In coherent demodulation, we need to generate the local carrier. Carriers మీరు రిసీవ్ చేసుకున్న సిగ్నల్ని యూజ్ చేసుకొని యూజ్ చేసుకొని ఏం చేస్తున్నానంటే క్యారియర్ సిగ్నల్ జనరేట్ చేస్తున్నాను. ఓకేనా? క్యారియర్ సిగ్నల్ ఎక్కడి నుంచో జనరేట్ చేయట్లేదు. నేను రిసీవర్ దగ్గర ఏం రిసీవ్ చేసుకుంటాను? బీపీఎస్కే సిగ్నల్ ట్రాన్స్మిట్ చేశాను. ట్రాన్స్మిటర్ దగ్గర బీపీఎస్కే సిగ్నల్ ట్రాన్స్మిట్ చేశాను. రిసీవర్ దగ్గర ఏం చేస్తున్నాను? బీపీఎస్కే సిగ్నల్ని రిసీవ్ చేసుకుంటున్నాను. రిసీవ్ చేసుకున్న బీపీఎస్కే సిగ్నల్ని యూజ్ చేసుకొని నేను క్యారియర్ని జనరేట్ చేస్తున్నాను. అర్థమైందండి? నేను రిసీవ్ చేసుకున్న బీపీఎస్కే సిగ్నల్ని యూజ్ చేసుకొని ఐ హ్యావ్ రిసీవ్డ్ ఏ సిగ్నల్. దిస్ ఈస్ ద రిసీవింగ్ యాంటీనా. ఓకే, by using receiving antenna I receive the signal which is called BPSK signal. By using this particular BPSK signal I am going to generate carrier, local carrier. How we can generate the local carrier based on the received BPSK signal? Let me explain now. Right, so these are the things, these are the received signal. First receive చేసుకున్న సిగ్నల్ ఎక్కడికి వెళ్తుందమ్మా? ఏ బ్లాక్కి వెళ్తుంది? మీరు రిసీవ్ చేసుకున్న బీపీఎస్కే సిగ్నల్ ఫస్ట్ ఏ బ్లాక్కి వెళ్తుంది? మీరు రిసీవ్ చేసుకున్న బీపీఎస్కే సిగ్నల్ ఫస్ట్ ఏ బ్లాక్కి వెళ్తుంది? చెప్పండి. ఇక్కడ స్క్వేర్ లా డివైస్ కింద. స్క్వేర్ లా డివైస్, దిస్ ఈస్ ది ఫస్ట్ మాడ్యులేటర్ బ్లాక్ అండ్ నౌ ఐ విల్ ఎక్స్ప్లెయిన్ దిస్ వన్ నౌ. సో this is the received signal. This received signal is given to the square law. Second point is given to the square law device. Square law okay, this is the input signal. So now my concentration is only on getting the carrier signal. Carrier signal ని జనరేట్ చేయాలి. లోకల్లీ జనరేటెడ్ క్యారియర్ సిగ్నల్ని జనరేట్ చేయాలి. లోకల్ క్యారియర్ సిగ్నల్ జనరేట్ చేయాలి. సో ఎప్పుడైతే మీరు ఈ ఇన్పుట్ సిగ్నల్ని ఇన్పుట్లో అప్లై చేస్తారో అవుట్పుట్లో స్క్వేర్ లా యొక్క అవుట్పుట్ ఎలా వస్తుందంటే కాస్ స్క్వేర్ ఆఫ్, దిస్ ఈస్ ద ప్రాపర్టీ ఆఫ్ ద స్క్వేర్ లా డివైస్ అండ్ కాస్ స్క్వేర్ ఆఫ్ థీటా. స్క్వేర్ లా అంటే సో మీకు ఇక్కడ స్క్వేర్ అయిద్దండి టర్మ్స్. ఇక్కడ ఈ టర్మ్స్ యాంప్లిట్యూడ్ టర్మ్స్ కూడా స్క్వేర్ అవుతాయి. నేను మై కాన్సన్ట్రేషన్ ఈజ్ ఓన్లీ ఆన్ carrier component, carrier frequency component, not carrier amplitude component. So my concentration is only on the carrier frequency, not carrier amplitude. So therefore I have neglected the amplitude terms. Therefore I have neglected the amplitude terms here. I concentrate only on the frequency term. So therefore I represent only the frequency term. I ignore the amplitude term here. So is it okay? The square law device amplitude is this one. So now first the received signal is first given to the square law device and output of the square law device will be like this. So if you simply by using mathematics, if you simply remove this one, cos square 2 pi f naught t plus theta can be written as 1 by 2 into cos 2 into 2 pi f naught t plus theta. Cos square theta can be written as 1 plus cos 2 theta divided by 2. 1 plus cos 2 theta divided by 2. So this one will be the output of square law device. Output of square law device. Now, so output of the square law device is given to which one? Anybody? What is the second block? First, the received BPSK signal. All of you please look at this one. So now I will remove this one. I have received by using receiving antenna. I have received the BPSK signal. BPSK signal. Modulated signal. First it is given to the square law device and output of the square law device is half into cos 2 into 2 pi f naught t plus theta. This one will be the output of the square law device. right? So now, so what is this? This one is called, what about this one? Anybody please? This is called DC term. This one is called DC term. DC term. And this is called carrier frequency term. Okay, now if you pass this particular, through the band pass filter, okay, band pass filter, what happens? What is the center frequency of the band pass filter? The center frequency of the band pass filter is 2 into f0. Okay, so if you pass this particular output, which is available at the output of the square law device, okay, the output of the square law device is given as input to the band pass filter. This is the output of the band pass, this is the output of the square law device. And now I apply this particular signal to the band pass filter. What will be the output of the band pass filter? Anybody? This DC term will be removed by the band pass filter. Okay, this particular DC term will be removed by the band pass filter. Is it okay, guys? Now all of you please listen here. Now I will explain. So this one will be the, third point is the output of the square law device is given to the, so next one is band pass filter, so which is nothing but your band pass filter, and this output, square law output is given as input to the band pass filter, and your band pass filter will remove the, DC component, removes the, and this one is called DC component, or DC term. Your band pass filter will remove the DC term. So what is the output? Anybody? What is the output? Anybody? Hello? What will be the output at the output of band pass filter? ఇక్కడ సింపుల్గా చెప్తున్నాను, ఇక్కడ ఏం రిమూవ్ చేస్తుందని చెప్తున్నాను, స్క్వేర్ లా యొక్క అవుట్పుట్ని తీసుకెళ్ళి దేని కింద వినిపిస్తుంది? స్క్వేర్. ద అవుట్పుట్ ఆఫ్ ద స్క్వేర్ లా డివైస్ is given as input to the band pass filter. What is the function of the band pass filter? Your band pass filter will remove the DC component, or will remove the DC term, and allows only cos term. Okay, what will be the output of the band pass filter? Please tell me. Guys, please tell me.
1/2 cos 2 pi f naught t plus theta.
What about this 1/2 term? This particular 1/2 term, which is nothing but DC term, will be removed by the band pass filter, and your output is equal to the only 1/2 into cos 2 into, okay, 2 pi f naught t plus theta. Okay, next the output is given to which one? What is the output of the band pass filter? Output of the band pass filter is equal to 1/2 into cos, okay, 1/2 into cos 2 into cos 2 pi f naught t plus theta. What is the frequency? Frequency n times on the 2 times of, here this is the multiplication factor, here 2. Okay, so now if you pass, what is the output of the band pass filter is given to which one? Output of the band pass filter is given to which one? Here all of you please look. Frequency divider. Okay, frequency divider. What is the frequency division? Divided by 2. Divided by 2, frequency divider. So it is divided by, frequency is divided by 2. Here it is divided by 2, frequency divider. The frequency component, frequency is divided by 2. Right? So now the fourth point is the output of the band pass filter is applied as input to the frequency divider. So now I consider the divided by 2 frequency divider. So now this output of the band pass filter is given as input to this one. So now what will be the output? Frequency is divided by 2. So what about the frequency here? This one is the frequency. Frequency any times undi, ikkada 2 times undi. Ee frequency em chestundi? Now what will be the frequency? If you divide this frequency by 2, then what will be the output? Guys, please tell me. Ikkada frequency enta undamma? ఒకసారి చూడండి ఇక్కడ ఫ్రీక్వెన్సీ ఎంత ఉంది, ఇక్కడ ఫ్రీక్వెన్సీ ఎంత ఉంది, 2 times ఉంది. దీని ఇన్పుట్లో పాస్ చేస్తున్నాను. ఇక్కడ చూడండి హాఫ్ కాస్, ఓకే హాఫ్ కాస్, ఇక్కడ గ్రీన్ లెటర్తో చూస్తున్నాను చూడండి 2 ఇంటూ 2 pi f naught t plus pi. If you pass this frequency, so this, what is the frequency here, what is the frequency available here, divide this frequency by 2, what will be the frequency at the output side, cos 2 pi f naught t plus theta. Simply this particular term is removed, this 2. If you divide this frequency, this is the frequency term, I divide this particular frequency by 2. This is the amplitude of the cosine term, and this one is the frequency of the cosine term. Here only the frequency is divided by 2, not at all amplitude. Amplitude అనేది డివైడ్ అవ్వదు 2తో, only the frequency of the cos term is divided by 2. If you apply this particular cos term to the frequency divider, then the frequency of the cos term is divided by 2. ఓకే, సో నౌ ఇక్కడ చూడండి ఒకసారి, నేను చెప్తున్నాను ఈ సిగ్నల్ ఇదేంటిది, కాస్ టర్మ్ అండి. వాట్ అబౌట్ దిస్ వన్, యాంప్లిట్యూడ్ ఆఫ్ ది కాస్ టర్మ్. దిస్ వన్ ఈజ్ కాల్డ్ యాంప్లిట్యూడ్ ఆఫ్ ద కాస్ టర్మ్, అండ్ దిస్ వన్ ఈజ్ కాల్డ్ ఫ్రీక్వెన్సీ ఆఫ్ ద కాస్ టర్మ్. ఓన్లీ ఫ్రీక్వెన్సీ ఆఫ్ ద కాస్ టర్మ్ మాత్రమే డివైడెడ్ బై 2 అవుతుంది. కాస్ టర్మ్ యొక్క ఫ్రీక్వెన్సీ మాత్రమే 2 చేత డివైడ్ అవుతుంది. కాస్ టర్మ్ యొక్క, ఇక్కడ మనం కన్సిడర్ కాస్ టర్మ్, ఈ కాస్ టర్మ్ యొక్క ఫ్రీక్వెన్సీ మాత్రమే డివైడెడ్ బై 2 అవుతుంది. యాంప్లిట్యూడ్ అనే కాంపోనెంట్ డివైడెడ్ బై 2 అవ్వదు. ఓకే, సో ఈజ్ ఇట్ ఓకే? ఇఫ్ యూ డివైడ్ దిస్ ఫ్రీక్వెన్సీ టర్మ్ బై 2, దెన్ వాట్ విల్ బి ది అవుట్పుట్? ఇక్కడ 2 ఉందా, ఇక్కడ 2 రాసానా రాయలేదా, ఇక్కడ చూడండి ఒకసారి. ఏమ్మా ఇక్కడ 2 రాసానా, ఇక్కడ 2 రాసానా రాయలేదా?
లేదు సార్.
లేదు. సో ఫ్రీక్వెన్సీ అనేది ఇప్పుడు ఇదేంటిది, ఈ ట్రాన్స్మిటర్ దగ్గర ఎంత క్యారియర్ వాడాను నేను, ట్రాన్స్మిటర్ దగ్గర యూజ్ చేసిన క్యారియర్ ఫ్రీక్వెన్సీ ఏంటి, విచ్ ఈజ్ ఈక్వల్ టు ది, దిస్ ఈజ్ కాల్డ్ లోకల్లీ జనరేటెడ్ క్యారియర్. Locally generated carrier. And so if you carefully identify this one, this locally generated carrier frequency is equal to the, this locally generated carrier frequency is equal to the transmitter carrier frequency. So therefore it is coherent demodulation. Is it okay, guys? So clearly I will explain this step by step. So first term is the signal is given to the first square law device. Signal first it is given to the square law device. After then the signal is given to the band pass filter. After then the signal is given to the frequency divider. So finally the output of the frequency divider is locally generated carrier signal. And it is also identified that the locally generated carrier frequency is equal to the transmitter carrier frequency. Therefore it is concluded that, so this type of modulation is called, demodulation is called coherent demodulation or synchronous demodulation. Synchronous అంటే ఏంటి, ఒకే విధంగా ఉంటాం, మీరిద్దరూ వర్క్ సింక్రనస్గా చేయండి అంటే, సో మీరు ఎంత అయితే వాడారో ఇల్లు అంతే వాడతారు. అది ట్రాన్స్మిటర్ దగ్గర ఎంత అయితే క్యారియర్ ఫ్రీక్వెన్సీ వాడారో రిసీవర్ దగ్గర కూడా అదే ఫ్రీక్వెన్సీని జనరేట్ చేసాం. సో వాట్ ఎవర్ ద ఫ్రీక్వెన్సీ దట్ ఈస్ యూజ్డ్ ఎట్ ద ట్రాన్స్మిటర్ సైడ్, the same carrier frequency is generated at the receiver side also. The carrier frequency that is generated at the receiver side, is called locally generated carrier, and this locally generated carrier frequency is same as that of the transmitted side frequency. Therefore this type of modulation is called coherent demodulation. ఓకే, సో ఇప్పుడు ఏం చేస్తామంటే, ఇప్పుడు జస్ట్ క్యారియర్ని మాత్రమే జనరేట్ చేసాం. ఇప్పుడు ఏం చేస్తాం మనం ఫైనల్గా? సో ఇప్పుడు finally it is received that. So first, by using transmitting antenna, receiving antenna, first there is signal is given to the square law device. Square law device. Okay, and next the signal is given to the band pass filter. Band pass filter. And next the signal is given to the frequency divider. Okay, now the output of this one is locally generated carrier. Locally generated carrier. Okay, up to now we have BPSK. What kind of signal you received? BPSK signal. BPSK signal. Okay, now here is a synchronous demodulator is there. Now here it is given synchronous demodulator. Synchronous, it is a synchronous so here the synchronous demodulator. So the two inputs are for this. The two inputs are locally generated carrier signal is applied as input to the, okay, and the next one is a received signal is another input. So what is a wave equation for this one? What is the wave equation for this one? This is a recovered signal. Recovered carrier signal. So what will be the equation for this one? So I will consider only this cos 2 pi f naught t plus theta. Okay, and now it is given to the next one. It is given to the next one. What about this one? This is a received signal. Received input signal. Okay, so what is the function of the synchronous modulator? Synchronous demodulator. Multiply the two things. So what is the output of the synchronous demodulator? What is the output of the synchronous demodulator? Anybody? What is the output of the synchronous demodulator? Anybody please tell me. So it performs simply the multiplication operation between this multiplier. This is also called as multiplier. Multiplier. So what is a multiplier? Recovered signal. So the output of the synchronous demodulator is equal to multiplication between the two. So which is called a received input, received BPSK input signal with recovered carrier. So simply, so this the two inputs are multiplied. It is a first input, it is a second. Two inputs are multiplied here or here, and it generates the output of the output, right? So what is the first output? What will be the shape of the first one? Received input. Received input will be in the shape like this. So that is equal to B of t into root 2p cos, okay, 2 pi f naught t plus theta into cos 2 pi f naught t plus theta. Okay, so రెండింటిని ఏం లేదు ఇక్కడ. సో locally generated a carrier is generated locally, and it is given to the demodulator. So here demodulator section will multiply the two inputs One input is received BPSK input signal. First input is received BPSK input signal, and second input is carrier signal. Is it okay? Right. So carrier signal is this one. This is the carrier signal. This one is the carrier signal, locally generated carrier, and this one is a received BPSK signal. Okay, so right. So what about the output of this one? What about the output of this one? The output of this one is equal to the, so what the output of this one is equal to B of t into root 2p. So here this is cos square, cos into cos, this is cos square 2 pi f naught t plus theta. Is it okay? So now I will write this one as B of t into root 2p into 1 by 2 into cos 1 by 2 into cos 2 pi f naught t plus theta. ఓకే, ఇది లోపల తీసుకెళ్ళిపోండి, ఇది రూట్ లోపల తీసుకెళ్ళండి, ఏమవుద్ది 4 అవుద్ది, అంతే కదా. 1/2ని రూట్ లోపల తీసుకెళ్తే 4 అవుతుంది. 2 divided by 4, so 1/2. So therefore, so here I will write it as, so B of t into p divided by 2 cos 2 pi f naught t plus theta. So this is the output of the coherent demodulator. Output of the coherent demodulator or coherent demodulation or synchronous modulator. Okay, so now this is now applied to the integrator. It is simultaneously applied to the integrator. So now it is simultaneously, this particular signal is simultaneously applied to the integrator okay, and it is also given to the bit synchronizer. Bit synchronizer. Okay, and here it is a bit synchronizer, and finally the output is called demodulated signal. So if you pass this through integrator, if you pass this particular signal through our integrator, so this is called demodulator synchronous demodulator output. If you pass this output through an integrator performs the integration, it gives the bit sequences, binary bit sequences. ట్రాన్స్మిటర్ దగ్గర ఏం చేసాం, బిట్ సీక్వెన్సెస్ని ఫేజ్ షిఫ్ట్ కిందకి కన్వర్ట్ చేసాం. మళ్ళీ అదే ఫేజ్ షిఫ్ట్ కింద బీపీఎస్కే సిగ్నల్ ఇక్కడ ఎలా చేంజ్ చేసేస్తాం, బైనరీ ఫేజ్ షిఫ్ట్కి. ఇది ఎలాగంటే ఒక డెరివేషన్ చేసి మనకి చూపిస్తాను. ఇంటిగ్రేటర్ అవుట్పుట్ అనేది ఎలా, ఓకే, ఇంటిగ్రేటర్ ఈ సిగ్నల్ని తీసుకొని ఎలా ఇంటిగ్రేట్ చేస్తుంది, ఇంటిగ్రేట్ చేసిన తర్వాత మన బైనరీ సీక్వెన్స్ ఎలా ఇస్తుంది, బైనరీ సీక్వెన్స్ అనేది అవుట్పుట్లో ఎలా ఇస్తుంది. సో దట్ ఈస్ ద మెయిన్ ఎజెండా, రైట్. ఇంటిగ్రేటర్ విల్ టేక్ this particular signal and how it generates the binary sequence at the output of the integrator. Okay, so this is the overall block diagram of the BPSK receiver. This is the overall block diagram of the BPSK receiver. Is it okay, guys? Later on I will derive one more derivation, that is how integrator generates the bit sequence. So this is a BPSK signal. This BPSK signal will be in the form of like this. Phase shift is there. So this means if you identify this one will be the phase shift and this one will be the phase shift. So corresponding to the phase changes, corresponding to these received phase changes, how it generates the bits at the output here. So if you pass this particular signal, whatever the output that is generated by the synchronous demodulator, whatever the output that is generated by the synchronous demodulator, that is given to the integrator. If you apply the output of the synchronous demodulator to the integrator, it generates the bits here. That it performs the integration for this waveform. If you perform the integration for this waveform, then how it generates the bits at the output of the integrator? Let us see. Right. So now, so in the next class, I will tell that particular thing. సో ఇంటిగ్రేటర్కి ఈ సిగ్నల్ అప్లై చేసినప్పుడు ఈ సిగ్నల్ తీసుకొచ్చి ఇక్కడ అప్లై చేయండి. ఈ సిగ్నల్ మీరు ఇది రిసీవ్ చేసుకున్న సిగ్నల్ అమ్మా, ఈ రిసీవ్ చేసుకున్న సిగ్నల్ ఇక్కడికి వస్తుంది కదా. ఈ సిగ్నల్ని బేస్ చేసుకొని ఇంటిగ్రేటర్ అనేది అవుట్పుట్లో బిట్స్ని ఎలా జనరేట్ చేస్తుంది. ఓకే, కరస్పాండింగ్ ఫేజ్ చేంజెస్ ఆర్ హౌ integrator converts the corresponding phase changes into bits. Let us derive the one derivation. Based on that particular derivation, I will conclude that integrator generates the binary sequence corresponding to the phase changes received in the BPSK signal. Is it okay? Right. So this is the block diagram. This is the generalized block diagram for the BPSK demodulator. BPSK demodulator. Is it okay? Every one of you understand? Have you understand this one? Every one of you, please listen. What is meant by coherent demodulation? What is meant by? These are the steps involved in the demodulation, right? First step is received signal. First, the signal is passed through the square law device, and after then the signal is passed through the band pass filter. After then the signal is passed through the frequency divider, and output of the frequency divider will be the locally generated carrier. Based on the received signal, based on the received BPSK signal, I recover the carrier signal. I reconstruct the carrier signal. That is called locally generated carrier signal. Is it okay? So now the block diagram for this one is simple. Block diagram for this one is this one is a synchronous demodulator, and it is a carrier, and it is a received signal. The carrier is generated by using this received signal only, by using these three blocks. Is it okay? So with this, I completed the demodulation part of the your BPSK receiver. Okay. So in the tomorrow class, I will discuss about the characteristics of the integrator, how it generates the bits corresponding to the phase changes, and what is the bandwidth of the BPSK signal, and what is the power spectral density of the BPSK signal. I will discuss all these things in the next class. Okay, thank you one and all. You may leave the class.
Thank you, sir.
Thank you. So this, every one of you, please take down this one. So this is your block diagram.
హలో సార్.
చెప్పండి అమ్మా, వెళ్ళిపోవచ్చు, మీరు వెళ్ళిపోండి.
సార్ నెక్స్ట్ మంత్ నుంచి సెమ్ ఎగ్జామ్స్ అంటున్నారు సార్, November 2 నుంచి న్యూస్ వచ్చింది, నిజమేనా?
November 2nd?
November 2 నుంచి 2nd, 4th, 6th సెమిస్టర్స్ కి ఎగ్జామ్స్ అంటున్నారు.
అంటే అఫీషియల్గా అయితే ఏం ఇన్ఫర్మేషన్ లేదమ్మా, కానీ అన్అఫీషియల్గా ఒక నోటీస్ రిలీజ్ అయింది. అది మీ ఫస్ట్ ఇయర్ వాళ్ళకి మాత్రమే, అంటే ఫస్ట్ ఇయర్ 1-2 ఎగ్జామ్స్కి మాత్రం ప్రస్తుతానికి సర్క్యులర్ రిలీజ్ అయింది. ఓకే, నెక్స్ట్ ఏంటి అనేది ఇంకా మీకు సెకండ్ ఇయర్ సెకండ్ సెమిస్టర్ ఎగ్జామ్స్ గురించి ఎవరు ఇంకా ఏం డిస్కస్ చేయలేదు.
ఓకే సార్.
ఐ థింక్ you need to write the second year second semester exams, I think, isn't it?
Yes sir.
I have no idea about the second year second semester examination. But yesterday I received one circular regarding first year second semester, not about the second year second semester.
Yes.
So it
Okay.
tentatively first year second semester's exams will be from 11th October, not November, October.
సార్
మ్యాక్సిమం మీకు కూడా ఎగ్జామ్స్ ఉంటాయండి, ఈ మంత్లోనే ఉంటాయి. ప్లాన్ చేసుకోండి దానికి అకార్డింగ్గా మీరు.
ఓకే సార్. థ్యాంక్ యూ సార్.
థ్యాంక్ యూ. వెళ్ళిపోవచ్చు, మీరు అందరూ వెళ్ళిపోవచ్చు, నేను చెప్తున్నాను కదా, వెళ్ళిపోండి.